I want to spend some time talking through the periodic table. So this is something that is incredibly important in all of chemistry, but specific to National 5 chemistry, there's some really important key things that we need to know about it. So the one I've got in front of me just now is just from the National 5 data booklet, which you should download from online on the SQA website. I'll leave a link down in the description. But just looking at it, there's some things we need to know. So first of all, what is it? It's basically just a list of all the elements that we know of in the universe. So an element being a substance that's only made of one type of atom. Okay, so a pure substance. These are all the pure substances that we know of in the universe. There's over 100 of them, and everything that we know of in the universe is made from these elements or some combination of these elements joined together in some way. And they're all arranged in a particular way in this table. So what do we need to know? Well, first of all, this is what it looks like. Why does it look like this? Well, it's arranged in a couple of different kind of key structures. So you can look at it going across the way, you can look at it going up and down the way. Those are the two kind of things I want you to start thinking about. One of the first things you might notice is there's a big black line that starts from here, cuts across the middle like that, and then zigzags down to the bottom right. So what that line is doing is separating two of the main groups in the periodic table. The left-hand side being all the metals that we know of, and the right-hand side being all the non-metals. So anything to the right-hand curve of this line, so hydrogen and this chunk over here, are all non-metals, whereas every other element is a metal. What else do we need to know? Well, it's called the periodic table. Why is it called that? Because one way we can look at all of the elements as being arranged is periodically. That is going from left to right. So starting at hydrogen, which has a number 1 next to it, all the way across to helium, which has a number 2, and then back down to the left for 3, 4, 5, 6, and so on, all the way up to, in this case, 116. So why is that? Well, they're arranged by something called the atomic number, and that, in fact, is what that number is. So that 1, that 2, that 3 tell us something about those elements. And in the periodic table, that's their kind of label. And that shows you whereabouts in the table they might be found. So you know if it's a small number, it's going to be up near the top. And as the number increases, it moves down the periodic table across the way from left to right. So when you think about going across the way, think about periods. Think about atoms being arranged, elements being arranged, periodically, which means across the way. Now we'll come on to why that is in a later video, what the atomic number actually is, what it tells us about the atoms. But another way to look at it is, you'll notice at the top of each of the columns up and down the way, they are listed with headings, column 1, column 2, column 3. Now a better word to describe these columns is groups. So these are called groups because anything in the same column, so for example column 1, that being group 1, so hydrogen, lithium, sodium, etc., all share similar chemical properties. They all behave in a similar way. Now that changes slightly as you go down, so it will get increasingly or decreasingly true depending on what property you're talking about. But by and large, lithium behaves very similarly to sodium, behaves very similarly to potassium, etc. So we can group elements that behave the same way, that react the same way chemically, up and down the way. So far we have periods going across, groups going up and down in columns. Now specific to groups, there are a few key groups that you need to know about. There's 3. So we have to know a bit about the alkali metals, which is the first group. So that first column on the left, starting at hydrogen and going all the way down, are the alkali metals. What do we need to know about them? Well, they're a very reactive group, and they react rapidly with water, producing an alkaline solution and hydrogen gas, which we'll get onto in a later video. But just realise that they are very reactive elements, as are group 2, but group 1 is the focus here. Jumping across, we're going to skip all of the middle of the table for just now and go right across to the right hand side to group number 7, which are the halogens. So they start with fluorine at the top, chlorine, bromine, iodine, and astatine. Again, because they are all in the same group, they behave in a very similar way. Now, they are gases starting at the top, bromine is a liquid, and moving down, they get increasingly more dense. And opposite to the alkali metals, as you go down the halogens, they actually get less reactive. But the main point that we're making here is that elements in the same group behave in a similar way. So fluorine behaves very similarly to chlorine, for example. Again, a very reactive group. And then the last group we want to know something about are called the noble gases. So that's group 8 or group 0, as it's sometimes called. We can call it both. Again, we'll get onto that, why that is in a later video. But again, if you're a noble gas, you will behave like any other noble gas. That's why they're grouped together up and down the way. Okay? And you'll have noticed that if you've counted along with me, 1, 2, group 3 doesn't actually start in the next column. We have to skip all the way over to boron at the top, aluminium, gallium, etc. for group 3. So this big chunk in the middle seems to have been kind of forgotten about. And in effect, when we're talking about groups in the periodic table, it kind of does get forgotten about. But we call this chunk in the middle the transition metals. So they are found between groups 2 and 3. Now, well-known examples of this might be iron or copper or gold. They're generally quite dense and heavy, but for the time being when we're talking about groups, that big chunk in the middle, in effect, is one group, but we don't number it. So when we're talking about main group chemistry, we mean 1, 2, jump all the way across to 3, 4, 5, 6, 7, and then 8 or 0 at the end.